Okay, so in this video we are going to go over the chain rule, and this time we're going to have a particular outer function. The outer function is going to be a power function. So remember, a power function is just any function that's just x to some power and then possibly times a number, and that's what that k is. That's just some number that we'll fix throughout the rest of this video. In fact, it'll be the number 2, as you'll see. So here's the chain rule right here. Remember, the chain rule tells you how to differentiate the composition of functions. So in this case, it'll be the composition of a power function with something else. And what you do is you differentiate f, you plug in g into that function, then you differentiate g and you multiply those two things together. And since the outer function is going to be f, we're going to be using the power rule right here. Okay, so let's just jump right into it. We're just going to do examples precisely of these kinds where the outer function is a power function. So here we go. We want to take the derivative of 2 times the quantity square root of x minus 3x to the power 99. How is this going to go? Well, we know the power function is the outer function is the power function. So what we're going to do is take the derivative of the outer function first. So what is that going to be? It's just going to be, so here's the outer function, just, this part. And the stuff inside in the parentheses is the inner function. So we take the derivative of the outer function first, that's just power rule, 2 times 99 times whatever's inside to the 99 minus 1 power, that's just 98. So we plug the rest of the stuff in there. So it's just ordinary power rule, and now here comes the chain, just like this. We get 1/2 x to the minus 1/2 minus 3. Remember, that complicated looking expression, that was just the derivative of square root of x. Why is that? Because square root of x is just x to the 1/2, and when you take the derivative of it, you just use the power rule. All right, and that's it. So if you want to simplify this expression a little bit, you can write it like this: 198, that's just 2 times 99, times square root x minus 3x to the 98. And then times 1/2. And you could put the square root on the bottom if you want. That's fine there. Usually it's not nice to leave square roots in the denominator, so you have to do this little trick where you multiply the top and bottom by square root of x. So when you do that, you get square root of x over x. So this is just a little simplification. So this part turns into 1/2 square root of x over x. Okay, so this would be the final simplified answer. Okay, so let's do another example. This time it's going to be slightly different power function, just put a negative exponent there, but now inside the power function, in other words, the inner function has a log in it. So how is this going to go? So again, the outer function is a power function, so let's just use power rule. So 2 times negative 99 times 1 plus ln x to the minus, what's minus 99 minus 1? That's minus 100. So you see, that whole thing was just the power rule, but you have to chain what's inside, so you're going to get times the derivative of what's inside, that's 0 plus 1 over x, because that's the derivative of ln x. Okay, so we simplify this thing, we get negative 198 times 1 plus ln x to the minus 100 times 1 over x. And if you really wanted to, you could tidy this up a little bit. Let's write it like this as one single fraction. So we'd have negative 198 over 1 plus ln x to the power 100, because a negative exponent in the numerator is a positive exponent in the denominator, and then times x, because you're multiplying by 1 over x. And there you go. That is the derivative of 2 times 1 plus ln x to the minus 99 power. One last example. This time we have a power function, but an exponential function is inside. So how's this going to go? Well, anytime you see square roots or radicals, you just convert it immediately to an exponent because you know you're using the power rule. So this 99th root or radical of something is just 1 over 99 power, and we want to take d dx of that, in other words, the derivative. So how's this going to go? You use power rule first, that's 2 times 1 over 99 times x minus 3x to the 1 over 99 minus 1. See, straight up power rule. Now here comes the chain. So we have times the derivative of what's inside, that's 1 minus, what's the derivative of 3 to the x? Well, what's the derivative of an exponential function? It's just itself times ln of the base. Remember, that's how that thing goes. And so, just tidying this up a bit, 2 over 99, the answer is 2 over 99. What's 1 over 99 minus 1? Well, that's going to be negative 9. It's going to be negative 98 over 99. So we can put that on the bottom if you want. So we have x minus 3 to the power x to the positive 98 divided by 99, right? Let me just so you can see this quick calculation here. 1 over 99 minus 99 over 99 is equal to negative 98 over 99. Since the exponent is negative, it becomes positive when we bring it to the denominator. And so we get, and then times, well, what's the thing that was on top? 1 minus 3 to the x times ln 3. All right, so there we go, everything written as a single fraction. And so let me circle that. That's the final answer. And that is all. So remember, you're always, when the power rule is on, when the power function is on the outer function, you always use the power rule first, and then the chain is whatever's inside that power function.